Topic density. How we define the term density? Density is defined as how much matter or how much mass is there in a unit volume. Example, we have an object which is having a mass of 3 kilogram, 3 kg, and it occupy, say, 9 meter cube. And we want to find the density. To find the density, what is the meaning of term density? Density means how much matter is there or how much mass is there in a unit volume. So if there is a total mass of a 3 kilogram in 9 meter cube, how much mass is there in 1 meter cube? That is refers to density. So if you want to find the density of this object, it is denoted by a Greek alphabet rho, which is m by v, where m is representing the mass. In this example, the mass is 3 kilogram and the volume is 9 meter cube. So we'll have 3 divided by 9, which is 1 by 3 or 0.33 kilogram per meter cube. So density of this object is 0.33 kilogram per meter cube. Why density is an important physical quantity? Because using the density, we can identify the type of the material and we can also predict that whether the object will float or sink by comparing the density of an object with the density of a fluid. So two reasons why density is important. One is to identify the type of the material, and the second is to know whether the object floats or sinks if it is released in the fluid. So if we say that density of this object is 0.33 kilogram per meter cube, and we have a container which is filled with a fluid, and that is having a density of 0.9 kilogram per meter cube. So density of the fluid is 0.9 and the density of the object which we have is 0.33. If I place this object, if I transfer this object into the container which is filled with a fluid, so what will happen to this object? Because the object density is lower than the density of the fluid, so we can predict that this object will float. So if the density of the object is either less than or equal to the density of the fluid, that type of object will float on the surface. But if the density of the object is greater than the density of the fluid, that what will happen? The object will sink. So using the density, we can predict whether it will float or sink. Is it clear, the concept of density? And using the density, we can work out the type of the material. Like example, if we have 3 different types of materials, they have, like if we have 3 materials, we don't know whether they are same type or different types. Like example, the object A is having a mass of 2 kilogram and it has a volume of 2 meter cube. The object B is having a mass of 1 kilogram and it has a volume of 2 meter or 1.5 meter cube or 0.5 meter cube. And object C is having a mass of 5 kilogram and it is 5 meter cube. We want to find whether these materials are made of, like it is made up of same material or different. So how we can work out? Using a density, we can work out this. So density is mass over volume. So if we work out the density of the first sample, it is 1 kilogram per meter cube. When we work out the density of the second sample, so that is equals to 2 kilogram per meter cube. When we work out the density of the third sample, which is 5 divided by 5, that is 1 kilogram per meter cube. So because sample A and sample C are having the same density, so what this gives an indication? This gives an indication that these two objects are made up of same, or they are made up of same material. So we can have 2 or more different types of like different masses and the volume of the object, but if we find they have the same density, we can conclude that they're made up of same material. So using density, you can identify the type of the material as well as you can identify whether the object will float or it will sink. The density changes with temperature. The density changes with temperature because what actually happened? Density is mass present in a unit volume. So what we do, if we increase the temperature, the substance expand, means the spacing between the particles will increase. So as the spacing between the particles will increase, so the volume will increase. So for a fixed mass, when we increase the volume, what will happen to the density? The density will decrease. That is why if we have air at different temperature, one is at say 20 degrees, another one is at 60 degrees. Which sample of the air at which temperature will have a high density, at 20 or at 60? My question is, at which temperature the density of the air will be high, at 20 or at 60?
20.
So at 20, the density will be high because when the temperature is low, the particles are close to each other. So the volume is smaller, so the density will be high. So that's why the cold air is denser and the hot air is having a low density, so it will always rise. So if you have studied in convection, when a air become hot, the hot air always rise. And when the cold air, the sample comparison, the cold air will sink. And why the hot air rise or the cold air sink? Because of the difference of the density. So the relation between the density and the temperature, because when we increase the temperature, the substance will expand. So the volume increases. When the volume increase, you have a large space, the same number of the particles in a large space. So what will happen to the density? The density will decrease. So hot air, when we have an air which is at a high temperature, the particles have large spacing between them. So the hot air will have a low density and it will rise. And in comparison, the cold air, which is having a high density, that will sink. So the change in temperature can also change the density. Anyone having a doubt or a question till this point? The definition of the density and the relation between temperature and density? The second topic, this is a word example, as you can see here, of density, mass over volume. The second thing is the upthrust. And according to Archimedes' principle, upthrust we have discussed, the upthrust is actually the upward force which the fluid apply. We call that as a upthrust. Upthrust is actually the upward force applied by the fluid. So Archimedes give an explanation about the upthrust, what upthrust, how we can calculate. Upthrust is there, the upward force of the fluid. It means it is valid for both liquids and gases. Like liquids also apply an upward, gases also apply an upward force, upthrust. So because the term fluid means liquid or a gas. So both liquids and gases applied upthrust, but we don't normally we ignore the upthrust of the gases because it is very small value. But yes, gases also apply an upward force or the upthrust. Sometimes that upthrust is also known as the lift. Now, what is the Archimedes principle? What he explained about the upthrust? He said, if you take a container which is completely filled with a fluid, and let's take an example of a liquid, say the container is there, which is completely filled with a fluid or the liquid. So what he said, if you immerse an object, there's an object, and you immerse this object in this fluid, so what will happen? This object will experience an upward force from the fluid. So a container is there, which is completely filled with the fluid. And there's an object. So there's an object which is immersed into this fluid. So as a result, what will happen when the object is added to this fluid? The liquid will come out, the fluid will come out. So according to Archimedes, what he said that amount of the liquid which will come out, that weight of the liquid which has come out is equals to the upthrust. So when we add this object, example, 2 Newton of the liquid is being displaced. So if the 2 Newton of the liquid is displaced, what will the upthrust? The upthrust will be 2 Newtons. Another object we immerse, which is having a different which is having a different volume. So if we immerse this object, and it will also displace the liquid when the object enters, it displaces the liquid. But how much liquid is being displaced? Example, the amount of a liquid displaces, example, say 1 Newton, or weight of a liquid displaces 1 Newton. So according to Archimedes principle, how much upthrust this object will experience? This object will experience an upthrust of 1 Newton. So upthrust is what? Upthrust is actually the weight of the liquid displaced by the object. So how much liquid is displaced by the object, that is refers to the upthrust. So we can derive a formula here that upthrust is equals to weight of the liquid displaced. Now, what about the weight? Weight is mass multiplied by gravity. So in place of weight, I can write mass into gravity. Weight is mg, so m and w equals m into g. So mass of the liquid displaced, gravity. And mass in terms of what? Because we have the formula density is mass over volume. So mass is equals to density multiplied by volume. So in place of mass, what we can write? We can write density into volume into gravity. So what is actually the upthrust? If we want to calculate the upthrust, so upthrust is equals to density of the fluid. How much, like what is the density of the fluid? V is actually the volume of displaced liquid. The volume of liquid displaced, like how much liquid will come out. Maybe 1 meter cube, 2 meter cube, 3 meter cube. But how much volume is displaced by the object? That is known as the volume V here. And what about G? G is a gravity, which is having a fixed value, 9.8. So in short, the upthrust depends on the density of the liquid, the volume of the displaced liquid, and the gravity. So if the density of the fluid is more, if the density of the fluid is high, the object will experience a greater upthrust. If the size of object, like how much liquid displaced, it depends on the size of an object. So if we have a greater size of an object, it will displace a large amount of the liquid. So as a result, it will experience greater upthrust. And it also depends on the value of the gravity, but we'll assume it is constant. That is 9.8. So if I have a container, say example, we drop 2 objects. One is the ship and another one is a nail into a very large container, or you can say in an ocean, which is having a seawater. So what will happen? When a ship is there placed, the ship start to float. But when a nail is placed, it will start to sink. So what is the reason for that? Why a large ship tend to float, but where a small nail tend to sink? That is mainly due to the upthrust. Because what happened, as we know, the upthrust depends on the density of the fluid, means in this case, it depends on the density of a seawater. It depends on the volume of a displaced liquid, and it also depends on the gravity. In this example, the gravity is constant and the density of the seawater, we assume it is constant. So upthrust depends on the volume of the object. So as a result, what will happen? Because the ship will have a large size, so it will displace greater amount of the liquid. So as it displaces greater amount of the liquid, so the upthrust on the ship will be very high. And when the upthrust is more than the weight, weight is acting downward and upthrust is acting upward. So when the upthrust is greater than the weight or equals to the weight, the object will float. But in case of a nail, what will happen? Because it is small in size, so the volume which the nail displays will be very small as compared to volume displaced by the ship. So as a result, smaller volume means smaller upthrust it will experience, and the upthrust which experienced by the nail might not be enough to balance the weight, or the weight will be greater than the upthrust. So as a result, the nail will sink. So using the upthrust, we can predict whether the object will float or sink, and how much upthrust the object experience depends on the fluid, depends on the volume of how much it displays, and it also depends on the gravity. Is it clear, the concept of upthrust and how we can relate? Anyone having a doubt or a question till this point? So using the upthrust, we can also predict whether the object will float or it will sink. So example, we have a hot air balloon on the surface of the earth. So this is a hot air balloon. The forces which are acting, because it is on the ground, so the weight is acting downward, and there's a normal contact force which is acting upward. Now, and whatever, because there will be an upthrust is equals to density, volume, and gravity. This volume is not the volume of object. It will be volume of object if it displays all the liquid, like it is completely submerged, then it is equals to volume of object. Now, so in short, we can say that density of a fluid, volume of displaced liquid, and gravity. So how we can explain that this hot air balloon can rise or it accelerate upward? So for the hot air balloon, it is filled with air, and there is a burner which is placed at the bottom. So burner is placed at the bottom. Now what happened? When the burner heats up the air, so the air expand, means the volume of the balloon will increase. As the volume of the balloon increase, this density, remember one thing, this density is not the density of the air of the object. This density is the density of the surrounding air. So the density of the surrounding air is not changing because the temperature of the surrounding air is not changing. So this is constant. Gravity is also constant. So it means the upthrust in this example depends on the volume of the object. The upthrust depends on the density of the fluid, because in this example, the air is a fluid for us. So density of the fluid or the density of the surrounding air, that is this rho. V is the volume of object and G is the gravity. The gravity is constant, and this rho is the density of the surrounding air, not the density of object. Because the fluid, in this example, the fluid is the air. So when the burner is switched on, the volume of the object increases, the volume of the hot air balloon will increase. As the volume increases, what will happen to the upthrust? The upthrust will also increase. So as the upthrust increase, when the upthrust is more than the weight, what will happen? This object will rise, because if the upthrust is more than the downward force or the gravitational pull, it will have experience, or it will experience an upward acceleration due to the difference in the forces. So density of the surrounding air is actually the density of the fluid. Is it clear, this example? So whenever we substitute the upthrust, whenever we talk about the upthrust is equals to density of the fluid, volume of displaced fluid, and gravity. The volume of a displaced fluid, if an object is completely submerged, like example, if this is a fluid, and the object is completely submerged in the fluid, in that case, the volume of the displaced fluid is equals to volume of object. So upthrust is equals to density of the fluid. The density of the fluid, like example, this is the hot air balloon. So this is the air. So this is the density of the air. What about the volume of the fluid displaced when object is completely submerged in the fluid, or when object is surrounded by the fluid? The volume of the displaced fluid is same as the volume of object. So in this case, this will be the volume of object, which is the volume of displaced fluid. And G is the gravity. So the density of the surrounding air is not changing, as we are not changing a temperature of air. We use a burner, and the burner provide the heat energy to the object. So when the burner provide the heat energy to the object, the size of an object increases. When the size of an object increase, as a result, what will happen? The volume of the object will also increase, or the volume of the displaced fluid will also increase. If the volume of the displaced fluid increase, so what will happen to the upthrust? The upthrust will also increase. Upthrust is a force, the unit is newtons. And there's a question from one of the student, like in the middle of a journey, the burner, we stop, and now the density of air in a balloon is equals to density of a surrounding. We expect it to stay stationary because it's equal, but it falls. So what will happen? The air, when we stop the burner or when we reduce the size, because at a higher altitude, when it rises the higher altitude, the temperature of the surrounding air decreases. Because when a balloon is rising up, the density of the air decreases. So even though it has a same volume, but the density of the surrounding air is decreasing. So upthrust depends on the density, volume, and gravity. So volume is not changing, but what happens as a balloon rises to a higher altitude, the air become cold, the density of the, and the other thing what happened, air become cold and it also become thin. Because at the ground level, the density of the air is much higher as compared to a higher altitude. So as a result, what will happen? The density decreases. So when the density decreases, the upthrust will also decrease. So when the upthrust decrease and weight is more, the balloon will not stay at the same altitude. It will start to sink. So upthrust depends on the density of the surrounding fluid, and it also depends on volume of the fluid displaced. Is it clear? The motion? Yeah, at low temperature, the density should increase. But what happened in the atmosphere? Yeah, because what happened? The number of the particle, the thickness, the number of the particles per unit volume, as the gravity is pulling the object towards the center, so there are more air particles near the surface or on the ground as compared to higher altitude. So even though the air is cold And here it's not about only temperature, it also depends on the gravitational pull. So because at the base or at the ground, the gravitational pull is stronger, the gravity is having a high value, so more particles are there in a unit volume. But even though the air is cold, the density should increase. But what actually happened, the gravitational pull is weaker, so the number of the particles which are present in a unit volume that start to decrease. So the upthrust actually, in short, the upthrust depends on the density of the fluid, the volume of object, and gravity. Like example, say there's an object. So upthrust depends on density of the fluid, volume of the displaced liquid, and gravity. Three different examples are there. The first example, the weight is more than the upthrust. So if the weight is more than the upthrust, so weight is more than the upthrust, so what will happen? The object will sink. If the weight and upthrust are equal and we release the object from the at the center, so it will remain at this place. If we release the object at the surface and weight and upthrust are equal, so object will remain at that place because there is no resultant force. And if the upthrust is greater than the weight of an object, then the object will rise. So upthrust, the upward force which the object experiences, depends on the density of the fluid. This V is not the volume of object, it is actually the volume of the displaced fluid. If the object is completely submerged, then it is same as the volume of object. But some examples, the volume is not completely submerged. Say we were having an object like this. So this object is not completely submerged. So what will be the volume of the displaced liquid? Volume of the displaced liquid will be how much volume of the object is inside. So upthrust depends on the density of the fluid, volume of the displaced liquid. So in this case, we'll only take how much volume is inside and multiplied by gravity. But if the object is completely inside, in that case, the volume of the displaced liquid is same as the volume of object. Is it clear? Any doubt in this? No, we don't have to take the difference in the density. The density of a fluid, we will only take the density of a fluid. So when we calculate the upthrust, we take the density of the fluid, we take how much, what volume of the liquid or the fluid will be displaced. If an object is completely submerged, we'll take the total volume of the fluid, total volume of the object. If the object is half submerged, we'll only take half volume of the object and multiplied by gravity. Like this word example, like in this word example, an object of mass 15 kilogram and it has a density of 1200 kilogram per meter cube, fully immersed. So if the object is fully immersed and if I need an upthrust, so upthrust is equals to density of the fluid, the volume of object into gravity. Why volume of object? Because this is actually the volume of the displaced liquid, but whenever object is fully immersed, the volume of object is equals to volume of the displaced liquid. And the density of the fluid, the liquid density is 1050 kilogram per meter cube. So first we'll work out the volume of object. How to work out the volume of object? Density is mass over volume. So the volume will be mass divided by density. So we got 0.0125 meter cube. That's a volume of object. And because the object is fully immersed, so whenever object is fully immersed in upthrust, that it is density of the fluid, the volume of the displaced liquid and into gravity. But when object is fully immersed, in that example, the object volume is same as the density of the volume of the object, volume of the liquid displaced. So upthrust, you can represent by F or you can represent by U, which is the density of the fluid, which is 1050, the gravity 9.8, and what volume we took? This is the volume of a liquid displaced, which is same as the volume of the object because it is fully immersed. So it is 129. And if we want to work out, the resultant force, like we have weight is there, which is mass multiplied by gravity. So 15 multiplied by 9.8, that's a weight. And we calculated the upthrust, which is 129. So we will check like 15 into 9.8. So as a result, what will happen? So 15 into 9.8, which is 147. So 147 Newton is a weight and 129 Newton is a upthrust. So what does it mean? It means that there is a resulting downward force. If there is a resulting downward force, so this object will sink. Why don't we take minus for the weight? If we need the resultant force, it's always a greater minus a smaller force. So weight is there. Example, you calculated the weight of an object, which is 147 Newton, and you calculated the upthrust, that is 129 Newton. So it's always a greater minus smaller. So when you subtract 147 minus, so you will got a resultant force of 18 Newton. It means this object will sink. Is it clear, this example? Anyone having a doubt? What if this object was not fully immersed or fully submerged? In that case, we cannot take the volume of object as same as here. That will be wrong. For if the object is not fully submerged, like object was half submerged, what volume I will take? If it was half submerged. So what volume I'll take? I will take half of this. So volume of the displaced liquid is actually the volume of the object inside the liquid. If it is fully submerged, I will take the full. In this example, the weight and the upthrust are not the pair forces. The weight is a gravitational force which the object experience. And because the object is in the fluid will apply an upward force. These are not the pair forces. So when we compare, the upthrust is more than the gravitational pull. So as a result, the weight is more than the gravitational pull. The weight is more than the upthrust. So weight minus the upthrust will be the resultant force, Ma, which is 18 Newton. So when two forces are acting in opposite direction and we want to find the resultant, we just subtract them. Why weight minus upthrust? Why not upthrust minus weight? Because when we calculated the weight, it was 147 and the upthrust was 129. So 147 is more than 129. That's why we subtracted in this manner. Why in this case they took weight plus the upthrust is equals to resultant force? Because they assume, in the example, they assume they're acting in the same direction. That's their assumption only. They assume that the weight and upthrust are acting in the same direction. But they, after solving, because they're in opposite direction, that's why it is substitute minus 20, 129. Is it clear till this point? The concept? Anyone having a doubt or a question? Okay. Next is the pressure. How we define the term pressure? Pressure is force acting on a unit area. So how much force act on a unit area, we call that as a pressure. So example, we have a unit area. Say we have like force acting on 1 meter square area. We call that as a pressure. So example, we have a surface which is having an area of 3 meters square, and the total force this whole surface will experience, the total force is 300 Newton. So what is the pressure? Pressure is how much force act on 1 meter square area. So the total force is 300 and the area is 3 meters square. So how much force is acting on 1 meter square area? So a force of 100 Newton on 1 meter square area. So that is refers to pressure. The pressure is also having another name, which we also call stress. So if we use the term stress or we use the term pressure, it's having a same meaning. So force acting on 1 meter square area is simply refers to pressure. And the pressure depends on how much force is we applied. The higher the force, more pressure the object will experience or exert. And if we have a large small area in contact, then the pressure will also increase. So if we have two surfaces of different cross-sectional areas and we apply the equal amount of force, A and B, equal amount of forces applied, like a force of 100 Newton and a force of 100 Newton, which will experience a high pressure, A or B? So in case of a B, the pressure is high because the same amount of the force but acting at a small area. As a result, there will be higher pressure, and the unit of the pressure is Pascal or Newton per meter square, which is also refers to Pascal. There are other units as well. It can be the millimeter of the mercury, usually for atmospheric pressure. It can be ATM, the atmospheric pressure as well. So about a minute left, I'll share another link and we'll continue this